Okay, here's our last example. Again, we're going to be looking at the quotient of two functions. This time we're looking at two trig functions. So given f of x equals sine x and g of x equals cos x, we're going to sketch the graph of h of x equal to f of x over g of x. Now this is actually a function that you have seen before. And so if you think about it, f of x is sine x and g of x is cos x. And think about what function this represents. It represents the tangent function. So I'm going to show you guys how to combine the two functions and graph the tangent function using the graphs of the sine and cosine functions. So what we need to think about is dividing the y value since it is the quotient of two functions. We also want to remember that the zeros for the new function exist wherever the numerator function is equal to 0. So the zeros of the numerator will be the zeros of the quotient of functions. Restrictions for the new function exist where g of x is equal to 0, so any values of x that would make the denominator equal to 0 will create restrictions for the function h of x. And if f of x is equal to plus or minus g of x, so if the numerator and denominator have the same value but opposite signs or the same signs, then what that means is that the quotient of functions will end up equaling plus or minus 1. Okay, so what this essentially means is if you have f of x over g of x, and f of x and g of x represent the same values, but maybe positive or negative numbers, then what that ends up giving you is an end result of positive or negative 1. That's essentially what that means, okay? So let's take a look at some things that you need to consider. First of all, wherever we have zeros for the numerator function, so the sine function, then I'm expecting zeros for the quotient of functions as well. So let's look at the blue function. That's our sine function. So I'm expecting to have a 0 here, a 0 here, a 0 here, here, and here. So the zeros are going to be in the exact same spot as the sine function. And wherever I have values of x that will make the denominator equal to 0, so wherever the cosine function is equal to 0, those are actually going to be restrictions. And the kind of restriction it's going to create are asymptotes. Okay, so I'm looking at some asymptotes in this function as well, which actually makes sense considering it is a tangent function and there are values of x where the tangent function does not exist. So looking at the cosine function, which is the red graph, wherever the cosine function has a 0, the quotient of functions has a vertical asymptote. So I'm drawing the vertical asymptotes with a color just so you can see them better, hopefully. And there you go. So we have 4 asymptotes within the domain of our graph. Okay, so plotting some points now. Remember that wherever the functions are equivalent to each other but maybe positive or negative, then the end result ends up being positive or negative 1. So one thing to think about is wherever the two functions intersect with each other, what that means is that their y-coordinates are exactly the same. Okay? So I'm going to look at some points of intersection to help me plot some easy points. So here's a point of intersection here. What that means is my y value for f of x and my y value for g of x are exactly the same, which means when I divide the same number by itself, the end result is going to end up being positive 1. So at this particular value of x, I know my function is going to go through positive 1. And so I'm going to look at that for all my points of intersection. So here's another point of intersection to the right of the one that we saw earlier. Because both the y values are equal to about negative 0.7, negative 0.7 divided by negative 0.7 will give me 1. So here's another value of x where I get a value of y that's equal to 1 when I look at the quotient of the functions. Here's another point of intersection. Again, negative 0.7 divided by negative 0.7 is equal to 1. And another one, that's probably 0.7. So 0.7 divided by 0.7 again is equal to 1. So I just plotted a bunch of points based on the fact that if they have the same value of y for both the functions, then dividing the two of them will give you a result of 1. Now the other thing that will make it easier for you to graph is if the two functions have the same value of y, but one's positive and one's negative. And as you move through the graph, what you'll notice is, if I move towards the right, at the value of the function that's here, so the scale here is going by pi over 2. So that would be pi over 4, pi over 2, and then 3 pi over 4. So at 3 pi over 4, my value of y is positive here and it's negative here, and they actually end up having the same value of y. One's positive, one's negative. So if I take a positive number, so f of x, and divide it by a negative number, which is the g of x, I end up with a value of negative 1. So they have the exact same value of y. So about 0.7 divided by negative 0.7 gives me about negative 1. And I can see that again here as well. So if I look at this value here, I have negative 0.7 divided by positive 0.7, which again is equal to negative 1. And I'll continue graphing any of those points that I may see. So again, negative 0.7 divided by 0.7 is negative 1. And again, positive 0.7 divided by negative 0.7 is equal to negative 1. Notice the order in which I'm dividing. Remember to divide f of x by g of x always. And if I sketch this graph, you get the tangent function, which you should know what the graph of this looks like. But here we use the quotient of functions to sort of get an idea of what the graph could look like. Okay, so there's a tangent function that we were expecting to see. Restrictions in the denominator are created because there are values of x that will make it 0, so you end up with some asymptotes. And wherever the numerator function is equal to 0, then the quotient of functions will also be equal to 0 at the same values of x. Okay, and that's pretty much it. Here's your assigned work. Be sure to watch the next video on lesson 3, which is on composite functions, tomorrow evening, and get ready to do your homework in class. That's all.